Welcome back to our next lesson in this physics block about pneumatics and hydraulics. Yesterday we began discussing hydraulics themselves, and we realized that hydraulics has to do with the movement of fluids. And once again, fluids actually can describe anything that changes form or can be affected by pressure. So air and liquids and plasma all are part of the category of fluids. In this case, though, we're really looking at the liquids in particular, the liquid type of fluids and how they move. We discussed briefly yesterday about how Galileo was one of our earliest influencers on some of the people that did some important work in the area of hydraulics. So Galileo was a teacher and an influencer of a man named Torricelli. And in the 1600s, Torricelli, as we learned yesterday, was the first person to come up with the idea of how to actually create a vacuum that could be measured. And Torricelli had done this by taking essentially a test tube, a closed glass tube, and filling it up with mercury. And he then took that tube and inverted it and placed it into a bowl that also contained mercury. And what he found by doing this was that the mercury dropped down to a certain level, creating this empty space in the top part of his glass tube. When this happened, he realized that he had actually created a vacuum. Now, when Torricelli does this and begins to bring this idea forward, there is a lot of debate from a lot of people, because in those days, people were still under the impression that Aristotle was correct. Now, of course, Aristotle, the great Greek philosopher, mathematician, a long time before had said, nature abhors a vacuum. And so he meant that there really wasn't a lot of vacuums, that there was always something else inside there. So scientists and intelligent people of the time had long debates about what was going on in that empty space that Torricelli had created. Was it a vacuum, or was there some other something in there, like, as they called it back then, ether? Well, turns out that Torricelli was right and Aristotle wasn't. Not to say that Aristotle wasn't a smart guy, it's just that as science continues on, we find things change, and we realize that things that we once held to be true can actually be proven false. Well, to take it a step further, inspired by Torricelli, we arrive at a man from France named Blaise Pascal. And Blaise Pascal was also a mathematician and a scientist, and he set about to continue proving the truth of Torricelli's work. And so one thing that Torricelli had done by working on this was to create a barometer, meaning a measurement tool that could tell the difference in air pressure. And his barometer was something that could tell us how high up in elevation we were. Well, Blaise Pascal, even though he wasn't the healthiest of guys, managed to get some friends of his to test out Torricelli's device, and they did it at a lower elevation, and then he got someone to climb all the way to the top of a mountain. And what they saw was, at a regular lower sort of sea level elevation, ambient air pressure, or as we said yesterday, our atmospheric pressure, the pressure of the atmosphere around us, had a weight of about 30 inches of mercury. When they took it up to the top of the hill, they found that it had dropped down. The size of the vacuum had increased, the amount of mercury they could measure from the bowl had decreased, and so by doing so, they could see the difference in air pressure at different elevations. Pascal was a big fan of the idea of the scientific method. And the scientific method means that we can retest things over and over again, and different people in different places, in different circumstances, should all be able to get the same result, regardless of who's doing it. If something is scientifically true, the scientific method would tell us that anyone can repeat your experiment and get the same results. So Pascal becomes an important person in the understanding of hydraulic fluids. a lot of his work really influenced what we use today. Pascal was so influential that we actually use his name as a unit of pressure. When we talk about pounds per square inch, which is how we oftentimes describe the pressure of something, whether it's oil or whether it's air, we also can use the term Pascal as a larger measurement of pressure. He lent his name to, or his name was taken, as a programming language, and there's a number of other things named after Pascal. So Pascal was this big, important, influential person in the 1600s, and we still are using some of the ideas that he came up with back then today. So in our talk about hydraulic fluids today, one of the ideas that Pascal brought to us was that we can transfer pressure through something like oil or a fluid. What he found out was that if a fluid like an oil is non-compressible, now remember that we found that we could keep compressing air into a space, so this doesn't apply as much to pneumatics, but in hydraulics he found that fluids were not compressible. You couldn't squeeze them into a smaller space. So it's not like you can just keep adding oil to a container that's full of oil. It will overflow. You can't force more oil in. Now we found with air, you can have a container of air and keep forcing more and more air until you have a higher PSI. But because fluids don't work that way, he came up with some of the ideas that we now use today in hydraulic machines, which is our real topic for today's discussion. In a hydraulic machine, essentially what is happening is we're able to create pressure in one end of a tube or a pipe or a hose, and if we put pressure on one side and we fill that tube or hose with a fluid like an oil, then whatever pressure we put at one end will actually be transferred with equal pressure on the other end. Therefore, we can force things on one end and our pressure is equal all the way to the end of whatever hose that we're moving that pressure to. This is a principle that basically operates most heavy machinery that we see today. Whether it's a backhoe or a bulldozer or some kind of other digger, these giant machines, which need incredible amounts of force to work well, oftentimes use hydraulic systems in order to power whatever it is that they're doing, the bucket that they're digging with generally. So how do these machines work? Well, if we know that a tube filled with fluid can exert pressure over distance, then all we have to do to make one of these machines work is figure out a way that we can keep that fluid in line and keep it moving from one place to another. So how do they work? Well, all of these machines have different arms and different moving parts. If you look closely at any of those heavy machinery machines, you will see that they have a series of cylinders. And the cylinders will be attached at a point, and then they'll have an arm that will go and attach at a separate point. It is this arm moving in and out of the cylinder, extending and retracting, that is going to make all of the different moving parts of our heavy machinery work. So what is going on inside our hydraulic cylinder? Well, as you can see, the hydraulic cylinder is a contained system and it's filled with fluid. So this arm that is inside of it is able to move in and out of this fluid back and forward depending on which way that pressure is pushing it. Well, inside this cylinder we also have then our oil or our fluid. What we see is that we have two different points then that the fluid can enter into the cylinder. The fluid is filling the hoses that run all the way through our entire mechanism so that the whole system is completely packed with fluid, generally some form of oil. Now, it's a fairly simple mechanism then, because all we need is a control that operates a valve. The control arm that someone uses when they're sitting there running a backhoe or they're running a bulldozer, when they pull that lever down to move their machine, what they're doing is releasing a valve. If you pull that lever down on in a certain direction, then more fluid is going to push up into this side of the cylinder, and that would push the cylinder, or that would push the arm inside the cylinder back this direction. As the fluid fills up this part of the cylinder, pushing our arm back, then of course the fluid in this part of the cylinder is now going to flow out of the cylinder, work its way down back into a reservoir. If you look at all those machines, they tend to have what looks like kind of a barrel attached to them at some point. Well, that barrel is storing a bunch of this hydraulic fluid. Inside there, they have all this oil. That oil then can go either direction. If it comes in here, the oil generally likes to work through a filter because you don't want to get all that oil clogged up with dirt and dust that you might have on a job site. So they run through a filter, and then of course there's a pump somewhere in this mechanism to help create this pressure. And so it's a fairly simple machine in which if we push the knob one way, we are increasing the fluid that is going to increase the pressure in that way. And if we pull the knob back the other way, we're going to reduce the amount of fluid on this side and increase the fluid that pushes the arm forward. So it's a fairly simple kind of an idea, but it's amazing that we are able to create such incredible amounts of pressure and extend them over distance just by using these tubes filled with oil. So that is how heavy machines work. They're able to transfer incredible amounts of power from one location to another, and it's all through the wonder of hydraulics.